Hi class, for this lab we're going to be providing sketches using actual Desmos and then just a quick handwritten sketch. So here's the, I'm going to put in there the actual address. So this is the Desmos website. And the first graph that we're going to do is equal to, or the first regression equation is equal to 3x minus 1. So all you have to do is go to the actual Desmos page, and in Desmos you're gonna write it as y is equal to, and this is 3x, and let me just double check, minus 1. So technically 3x minus 1, that is your actual sketch. And then once you're in this website, you can just click at 2 coordinate points, and you're just providing a basic sketch of that graph. So one of the pictures that you're going to be submitting is of this screen, and then the other one, it's going to be of your actual sketch. So let's go to the sketch, and let me actually draw it. Don't forget the actual arrows on the axis, since technically the equations that we're providing go on to infinity. I'm just going to use the y-intercept. So in this case, our y-intercept is 0, negative 1, which is technically there. You can see this coordinate point there. And then I'm just going to use the slope. So our slope on this one is equal to 3 over 1, which means we're going to go up 1, 2, 3, and then 1 unit to the right. So our line is going to be this one. This is technically your y hat. So this is your second picture, the picture of that sketch. You don't necessarily have to use the y-intercept. We could have used any other point that the software is providing you. The main idea is that you're getting a line that's actually going, or is actually increasing from left to right towards the positive infinity. That means that from left to right, the line is actually going up. And then a basic sketch, it's perfectly fine. So you can use 2 coordinate points given in the actual software, or if you remember the slope in the y-intercept, which is what I did here, that's perfectly fine. Let me go to the other one. And our second graph is going to be negative 2x plus 4. So let me go to the software. I'm just going to remove that one. So this is going to be y is equal to negative 2x plus the values of 4. And that's our actual line. Notice that this one is going on the opposite direction. This is because of the value of the slope. So this is going to be one of your pictures. As you're creating a sketch, it's just a basic sketch. So we're talking about the axis. And in this case, our y-intercept is 0, 4. So 1, 2, 3, 4. So y-intercept 0, 4, and the slope is negative 2 over 1. So technically 2 units down and 1 to the right. That is going to be the actual line. So this is your second sketch. Let me just go to the actual software. And I'm using this coordinate point. If you're using the software, you could have also used 2, 0. Plot those 2 points and then connect them. So this is your second picture. Let's go to the third one. Now, the third one has a minor addition to the problem. You're given units. So once units are given, most of the units are going to actually be on the first quadrant. So let me go back to decimals, and we're going to have to adjust this. So notice that because on both of the problems that we already graphed, we're not giving any units, your lines actually go on to infinity. So theoretically, they extend to the infinities. Let me remove these and then plot the new one. So the new one that we're given, it's going to be 2x minus 1. Okay, and we are given a specific requirement that x represents minutes. So for the software here, we're gonna have to do an adjustment, and this would be that x is greater than or equal to the values of 0. So you cannot have negative minutes, but this is what the line is going to represent. So technically, only after x is 0 or positive. So in this case, that's the line that we're actually providing. And the code here, we have to like manually input it to the actual values of the x's that are given. So since x represents minutes, the minimum a minute can be 0 unless it's stated otherwise. So in this case, we'll just be using 0 as the lower bound. So let me actually draw it. Actually, it's this one. So the y-intercept is 0, negative 1, and your slope is 2 over 1. So 0, negative 1, it's going to be here. Slope is 2, so technically 1, 2, and then 1 to the right. And we're not going to be using any values to the left, since technically we have a restriction on minutes. The minimum that a minute can be, or the domain of the x-is, another way of putting it, it's greater than or equal to 0, or unless they state otherwise. Most likely, if we were collecting data, our graph will actually start here, but we're not given any conditions. So other than that, it's minutes, so you cannot have negative minutes. So that would be okay to start it at 0. But in reality, if we were collecting data, it appears that x will be greater than or equal to technically 0.5. Most of the problems that we're using are only going to live on the first quadrant, where both of your units are positive, and well, you're not allowed for negative units. So I'll leave it like that. Once again, this is one picture, and then your other picture, it's going to be your handwritten sketch. Okay. As we're doing regression equations, some of these are going to be really messy. So we are going to have to technically use technology. So let me just provide the axis here. And if we're using technology, any 2 coordinate points would be fine since we're doing these by hand. So this is 0.17x plus 2.1. So let me go to decimals. So this is y is equal to 0.17x plus 2.1. And let me remove the previous one. So 0.17x plus 2.1. And then we do have a restriction. X represents subjects. So technically here, since we're not told anything else, your x's, the minimum that you can have for a subject is 0. So this is going to be a regression equation on the first quadrant. At this point, any two coordinate points is going to be okay to plot. So we're looking at 0, 2.1 is one of them. So let me go to the actual drawing. So 0, 2.1, and we're just going to estimate it. All the regression equations are going to be really messy to do by hand. So we'll just say this is technically 1, 2, and I'm going to put the coordinate point there, obviously not to scale. And then we would just find another coordinate point in here. So it looks like, let me select 5. So at x is equal to 5, we have an intersection. And let me modify that line. I'm just going to make it dotted because it's technically not part of the graph. It's 5 and 2.95. So the other one would be at 5 and 2.95. So technically 1, 2, 3, 4, 5. And I'm just going to say this is 3. So 5 around there. And then our line, let me make it into green. It's just going to be this portion here. I'm just going to put the arrow, which indicates that it's actually going into the infinity. So that would be sufficient. You basically just get two coordinate points anywhere in space and plot them. Regression equations for, well, lines that happen to be in this format are really messy. So you would be using basically software to plot them, meaning that you would be looking at, well, the line and finding at least two coordinate points. Let me remove that line. So this will be one of your pictures, and then the second one would be your actual sketch, so the handwritten sketch.